A student was performing experiments in the laboratory and he was asked by his teacher to separate an impure sample of sulfur containing sand as impurity. He tried to purify it with the help of sublimation. But he was not successful as the particles of the sulfur could not be separated completely from the sand. Do you know why the sublimation process was not successful? It is because sulfur is not of volatile nature and upon heating it melts. Therefore, the sublimation process could not succeed. Can you suggest which alternate method he could have used? Well, the student should have dissolved the impure sample in carbon disulfide. It is a liquid in which sulfur completely dissolves while sand does not. And from the solution, sulfur can be recovered with the help of crystallization process. In this video, we will discuss a few more separation techniques for purification of organic compounds. Organic compounds which are extracted from a natural source or synthesized in the laboratory are mostly impure and it is essential to purify it. The common techniques used for purification are sublimation, crystallization, distillation, differential extraction and chromatography. Let's discuss each of them in detail. Let's start with sublimation. This process is applicable to purify those solids which sublimes, that is, directly pass to vapor state upon heating without passing through the liquid state, or vapors and upon cooling gives back the solid again. For example, an impure sample of naphthalene can be purified by sublimation. The next method is crystallization, which is the most common method employed to purify an organic solid. It is based upon the difference in the solubility of the compound under investigation and the impurities associated with it. Here, the impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature but appreciably soluble at higher temperature. The solution is concentrated to get a nearly saturated solution and filtered. And on cooling the solution, pure compound crystallizes out. Repeated crystallization becomes necessary for the purification of compounds containing impurities of comparable solubilities. Let us discuss the distillation process. This is the process of converting a liquid into vapor upon heating and then cooling the vapors back to the liquid state. This important method is used to separate volatile liquids from non-volatile impurities. This process of distillation can be used to separate a liquid mixture in which two components present differs in the boiling points ranging from 30 to 50 Kelvin. In this process, the liquid mixture is taken in a round bottom flask and heated. Here, the vapors of lower boiling component are formed first and are condensed by using a condenser, and the liquid is collected in a receiver. The vapors of higher boiling point component form later and the liquid can be collected separately. But sometimes we come across a mixture of two liquids which differ in their boiling point temperature by 10 to 20 Kelvin. Here, the process of simple distillation will fail because the vapors of both the liquids will form simultaneously. In such cases, the process of fractional distillation is used, which employs specially designed columns called fractionating column. The fractionating column is fitted over the mouth of round bottom flask. In fractional distillation, upon heating, the vapors of both the liquids will be formed. As they rise into the column, the vapor of the high boiling liquid will have a tendency to condense first. In doing so, they release heat which is taken up by the vapors of the low boiling liquid. As a result, the latter remains in the vapor state. The vapors which escape the distillation flask are of low boiling point. They get condensed by the water condenser and the liquid formed is called the receiver. The vapors of the high boiling liquid fall back in the distillation flask. Thus, the separation of the two liquids can be done. There are certain liquids that have a tendency to decompose at or below boiling point. Such liquids are made to boil at a temperature lower than their normal boiling points by reducing the pressure on their surface. The pressure is reduced with the help of a water pump or a vacuum pump. There is another type of distillation known as steam distillation. This technique is applied to separate substances which are steam volatile and are immiscible with water. In steam distillation, steam from a steam generator is passed through a heated flask containing the liquid to be distilled. The mixture of steam and the volatile organic compound is condensed and collected. The compound is later separated from water using separating funnel. And when an organic compound is present in an aqueous medium, it is separated by shaking it with an organic solvent in which it is more soluble than in water. Here, the organic solvent and the aqueous solution should be immiscible with each other so that they form two distinct layers which can be separated by separatory funnel. Here, the two layers can be recovered by opening the stopcock and collecting them in separate beakers, and upon evaporating the organic solvent, the solid can be recovered. Let's discuss an important technique, chromatography, which is extensively used to separate mixtures into their components, purify compounds, and also to test the purity of compounds. The term chromatography was derived from Greek word chroma, meaning color, and graphene, meaning to write. In this process, we apply the mixture to be separated on a stationary phase, that is solid or liquid, and a pure solvent such as water or any gas is allowed to move slowly over the stationary phase, carrying the components separately as per their solubility in the pure solvent. Based on the principle involved, chromatography is classified into different categories. Two of these are adsorption chromatography and partition chromatography. In adsorption chromatography, the commonly used adsorbents are silica gel and alumina. When a mobile phase is allowed to move over a stationary phase, that is adsorbent, the components of the mixture move by varying distances over the stationary phase. The following are two main types of chromatographic techniques based on the principle of differential adsorption. A. Column chromatography and B. Thin layer chromatography. Column chromatography involves separation of a mixture over a column of adsorbent packed in a glass tube. The mixture adsorbed on adsorbent is placed on the top of the adsorbent column packed in a glass tube. An appropriate eluent, which is a liquid or a mixture of liquids, is allowed to flow down the column slowly. Depending upon the degree to which the compounds are adsorbed, complete separation takes place. Whereas in thin layer chromatography, a thin layer of adsorbent such as silica gel is spread over a glass plate. The plate is known as thin layer chromatography plate or chroma plate. The solution of the mixture to be separated is applied as a small spot about 2 cm above one end of the TLC plate. The glass plate is then placed in a closed jar containing the eluent. As the eluent rises up the plate, the components of the mixture move up along with the eluent to different distances depending upon their degree of adsorption and separation takes place. The relative adsorption of each component of the mixture is expressed in terms of its retardation factor, that is RF value, which is distance moved by the substance from baseline X by the distance moved by the solvent from baseline Y. Next, we will discuss paper chromatography, which is a type of partition chromatography. Here, A special quality of paper known as chromatography paper is used, which is made of cellulose fibers with molecules of water adsorbed on them. This acts as the stationary phase. A strip of chromatography paper spotted at the base with the solution of the mixture is suspended in a suitable solvent or a mixture of solvents. This solvent acts as the mobile phase. The solvent rises up the paper by capillary action and flows over the spot. The paper selectively retains different components according to their differing partition in the two phases. Now, we have come to the end of this topic. Can you suggest a method to separate acetone and methyl alcohol? Let me give you a hint. The boiling point of acetone and methanol is 56 degrees Celsius and 64.7 degrees Celsius respectively. Now, let us summarize what we have learned so far.
Manorama Horizon. Learning made simple.